Hi everyone, this is the first lesson of the Integration 2 Part 2 pack, but I'm just changing the last bit. And the reason being is the old video you had, it's kind of harder to use. But what we've found is that the exam board, or actually what we've checked is the exam board will give the form that they want the answer in. Because in the past, you might have had to realise that you had to split it up and then do partial fractions, and then it just kind of built into this monster. But the exams are kind of telling us, the exam board is saying that they'll give us the form that it's at, which makes it a little bit easier because you can kind of treat it like a partial fraction with how you rearrange it. So, you know what? I've not checked that I'm using the right mic. Sorry, everyone. So, yep, real tech is good. Sometimes I'll spend ages recording, and then it doesn't work because it's got the wrong mic on it. Right, so we multiply through by a common denominator, which is the x plus 5. I have to write a bit slower, haven't I? I've got loads to write. So I've got a lots of x plus 5 plus b. So if I use x is minus 5, I'll have minus 20 plus 5 is minus 15. A disappears, so that's b. Now I've got no other number to get rid of b to find a. So if I just use 0 with the minus 15, so 4 lots of 0 plus 5 is 5. 0 for that, so that's 5a. B is minus 15. So if I take the 15 over, it's 20. Don't know why I'm writing that down. I'm sure you can work it out yourself. So that tells us then that 4x plus 10 over x plus 5 is actually 4 minus 15 over x plus 5. We can almost guess that a value, because at the most basic level, 4x divided by x is 4. They're just working with a bit on the other side, but we got that there. Right, so now I'm going to integrate it, aren't I? So if I'm integrating it, let's have a dx in here, and a dx. So the 4 becomes a 4x. Look at this bit now. If I differentiate the bottom, it's a multiple of the top. So it's of this form, f dash of x over f of x dx. So it's going to form a log of the bottom. But I've got to be careful. Different teachers do it differently. But what I do is I say, what have I got? So I've got, hang on, do a different colour so it stands out. I've got a minus 15. What do I want? If I differentiate the bottom, what I really wanted was a 1. So I do what have I got, or what I want, which is the bottom bit differentiated, and then log of whatever's on the bottom line, the plus c. So just to tidy it up, there you go. And that matches with the exam. Randomly, AQA aren't that much fussed about using modulus signs in logs, but we are. So there's a question for you. So same idea. Let's have a look how they've done it. So I'm gonna multiply through and use x is a third, because that gets rid of all of that and finds out what c is. Then let's leave it over there. Then I've got 2 unknowns, but I'm just gonna have to create 2 equations, because I can't just get rid of the a or the b on its own. So this pack is used 1 and 2, and it's created 2 equations. which we solve. So I've got C is -5, I've got A is 1, I've got B is 3. There, and that's done it. And now if I'm going to integrate it, oh, Haley, where's your dx? Stick a dx on the end there. I like to put brackets around as well. Then. Let me try and get rid of this box. It's causing havoc. Yep, so the x squared becomes x cubed over 3. The 3x becomes 3x squared over 5. So my way, what have I got? I've got a -5, so that goes on the top. What do I want? If I differentiate the bottom, I want a 3, so that goes on the bottom, and then it's log of the bottom. So the way I do it, what have I got? 101 times log of whatever is on the bottom, plus C. There, and I think that's done. So that'll replace the video where it didn't have the form. There, job.